Hello, everyone. Thank you for taking the opportunity to look at this video. In this video, we will solve a velocity of a particle problem. So let's jump right into it. So here we have a picture to the right of a Formula One vehicle, which we know are some of the fastest cars in the world. And we are going to kind of put this as a backdrop for our problem today, okay? So our vehicle at a great distance looks like a particle. And so we're going to pretend that this F1 car is the particle that we're talking about, okay? Just to kind of give you a picture. So the problem states the following. The velocity of a vehicle, sorry, the velocity of a particle is given by v equals 20t squared minus 100t plus 50, where v is in meters per second and t is in seconds. Plot the velocity v and acceleration a versus time for the first 6 seconds of motion and evaluate the velocity when a is 0. So in this example, I know there's a lot going on, but the best way to do it is just to take it one bite at a time. So first we're giving the velocity, we're given the units of the velocity, we're given the units of time. And the problem is asking us to plot the velocity and acceleration versus time for the very first 6 seconds of motion. So we take this snapshot, right, in time that takes about 6 seconds, and we're visualizing and analyzing how is this particle, or in this example, this vehicle, how is it moving, okay? And then lastly, we are going to evaluate the velocity of when the acceleration is 0, okay? So right off, we first write our velocity equation. So v is equal to 20t squared minus 100t plus 50. So just by looking at the equation of the velocity, it has a quadratic form, right? Like a parabola, right? And the units are in meters per second. Now I take the derivative of the velocity function to get the acceleration. So the acceleration in this case is 40t to the first power minus 100, and the units for acceleration are meters per second squared. So our duration given in the problem is 6 seconds. So our range, our time range is from 0 seconds to 6 seconds. And now I created this table. So this table, I list the values of time. Now the numbers of you see here for velocity and acceleration, I got it by simply substituting the values for t for each equation shown above for velocity and acceleration. Now quickly, you see that at time 0, you see that the velocity is positive 50, but the acceleration is at negative 100. So in that snapshot of time, our particle, or our F1 vehicle in this case, it's decelerating initially, but the velocity is positive. Then we see after 1 second, our velocity is really slowing down, right? And our acceleration is actually accelerating. Okay, so we see both a mixture of decelerating and then towards the 6 second mark, both functions are positive, and so our vehicle is accelerating. And now this is the graph. So we see here that acceleration, as we've shown in the previous slide, it's a linear function, and so it's a straight line up. So this particle is accelerating, and so those numbers are increasing. And the velocity, on the other hand, like we mentioned before, it has a shape of a parabola, right? And so initially at 0 seconds, it's at positive 50 meters per second, but after 1 second, we see that the velocity is decreasing. And now we see that first point right after 1 second where both lines intersect. And what does that tell us? Well, that tells us that the particle is changing motion. It's changing its direction of motion. And so at first the velocity was decreasing, and then now it's accelerating, right? And now the last part of our problem is asking, well, what's happening with the velocity when acceleration is 0? And so we look at the 0 that's located on the y-axis. We move across horizontally, touching the blue line, and we draw a vertical line downwards between 2 and 3 seconds. And we see that the velocity kind of hits a peak, right? Like a trough. And so essentially, that's the pivot point where the particle increases in velocity. And we see a parabolic movement, right? So between 2.5 to about 5.5 seconds, velocity is below the acceleration line, but it's increasing. And then it crosses above after 5.5 seconds, and we see that this particle just exponentially in a hypothetical environment is increasing super fast, and acceleration again, of course, is also increasing. And lastly, remember that acceleration is basically the rate of change of velocity. And so if the car is accelerating, the velocity is increasing. If the vehicle is decelerating, then the velocity will be decreasing. Okay, thank you for watching this video. I hope you learned something. If you have any comments, please list it below, subscribe, and I hope to see you all in my next video. And suggest a few videos if you like.